Welcome back to my channel. I'm DW from Recon HVAC. I hope you're enjoying the video so far. This will be the last episode we do where we don't physically make a fitting. I just wanted to do a couple episodes on radial line development and triangulation to familiarize you guys with how the process works so that when we get into other stuff, nobody's really struggling with it. You sort of understand it. Next couple episodes, we'll do some S offsets, reducing S offsets, reducing elbows, and we'll get back into a little bit of ductwork stuff. I have some copper coming this week. We'll do another episode on the roof flashing. We'll finish that up. We'll solder it up. We'll do that together. I was thinking about doing a couple episodes on making a still, seeing I have the copper coming in. If you're interested in that, let me know in the comments. Please like and subscribe, and we'll see you in the next video.
Come out to the coast. We'll get together. Have a few laughs.
Okay, so today we're going to do a squared around. We took out an older system today, and I had some oddball holes in the floor. They were all panned off and stuff, and so we're going to make kind of a crazy boot here to fix what was in the floor. So we're going to go 20 by 6 to 8-inch round. We are going to make our fitting 8 inches tall. So we're going to make this a squared around, and I'm going to show you how to triangulate this fitting. What we have here is we have a top view of our fitting, and you're going to do this with all squared arounds. You're going to draw a top view out. This one is symmetrical, meaning no matter what half you look at, they're the same. Even the quadrants are the same. So we only really need to develop one quadrant to get all our points. If this was something where this hole was down here, you wouldn't be able to do it from one quadrant. If it was something where the hole was over here, then you'd be doing two different sides of two different sides. But because this one is pretty symmetrical, I can get away with doing one quadrant. So we're going to put our seam on the 6 line, and we're basically going to lay out 24 inches of this. If you have one where it's narrow on one side, don't try and make this a half where you have your fold outs like 10 inches wide on. It's not a good way of doing it. If you have less on the wings, it's a lot easier. So the first thing we want to do is develop our quadrant, and we do that with a radius. So our radius on the 8 was 4. So we're going to develop the quadrant now and bisect our circumference. I'm going to label this 1, 2, 3, 4, 3, 2, 1. This is also a point or seam, and A to the midpoint is also part of the triangulation. So the first point that we want to put onto our true length line is going to be the seam from the midpoint, and we're going to put this on the baseline. So we'll label this baseline just for instructional purposes, and we will label that S for seam. The next point we want to triangulate is A to 1. And you don't have to label these. You can label them whatever you want. So we'll call that 1. Now, if these were different, I would label this A 1 through 4 and seam A. And then over here, again, if it was different, I would label them B and so forth and so on. So now that we have A1, we want to go to A2. And A1 and 2 are almost the same. Now we want A3. 3. And now I want to get 4. I'm also going to add an extra point here because I want to check something. You don't need to do that. We'll just call this F4. I'm going to use that to check my height to 0.4 when we get to the working line. So now that we have all of our points developed, you don't need to do this, but for instructional purposes, I'm going to do it. Again, this is our true length line. Now I'm going to show you a different way to do spacing. I did this on the radial line development. episode yesterday. So we have 3.14 times 8, which gives us 25.132, which is 25 and an eighth is 0.125. We're dividing that by 4, which gives us 6.283, which is a little over 6 1/4, but we'll use 6 1/4.
Nerd alert, man. It's in our quadrant, too.
The old timers didn't believe in the way that we do it now. One of the gentlemen that taught me was born in like 1916, and he always told me not to do this, to measure between these points here, because they always believed that that arc was longer than a straight line, which that's probably true on bigger fittings. So I want to develop 3 spaces here, just like these 3 spaces, but I need to find a number to divide by 3. So I've drawn out our quarter of our quadrant here to 6.283, and I want to find a number to divide that by. Something that 3 goes into, which is 9. So now we just divide that up. And this is only to get spacing, no other reason. I just wanted to show you that because that's the way it used to be done. So now if you take that, that would be your spacing on your circle. And if you look, you're not losing anything. But again, I believe that when they did larger stuff, that probably was true, that they lost a little bit in that number. We've developed a working line here from A to B, which is 20. You don't have to do this. You could just scribe a line, bottom of a piece of metal, and figure out your starting point. But our starting point is going to be A to B, which is 20 inches. So the first point we want to find is 0.4, which is our center point. So we're going to go to our true length line, and we're going to draw 0.4. We'll swing an arc, and swing another arc. Now that we have our spacing, let's swing another set of arcs. Then we're going to go to 0.3. You're just going to work yourself down. 3, 2, 1. And sometimes this is easier to do in metal because you could punch the metal with your awl so that your points don't move. Again, we're going to draw our arc. We're going to go to 0.2. And 0.2 and 0.1 are the same. So we're going to put our spacing again. And again, those 2 points were the same. But even though they're the same, you see how they're coming out. So basically what we have there now is 4, 3, 2, 2, 1, and 1. So the reason that I drew that line from F to 0.4 is I wanted to just check this from my midpoint, and you'll see that we go right through. So that is how true length works. All right, so now we want to draw lines from A and B to 0.1. Now, if I did this correctly, when I mark these out, I should end up with 90 degrees here. So now we want to get our seam line, which is here. We want to swing that from 0.1. Because we were swinging from here to here. So now we want to take our half space from the midpoint to A. And there you have it. So we'll draw that line out. So this is 6, so this is 3 inches here. And sometimes if your drawing is really sloppy, you'll end up with all kinds of crazy stuff. So your drawing has to be pretty accurate. That's why sometimes it's easier to do it on metal. Now all we got to do is connect the dots. And when you connect your dots, look where you're going, not where you've been. If you have drafting tools, you could do this with a French curve. We also want to draw a line between point 4 and B. So now when you put this in the brake, you'll anchor this in the corner of the brake, and then you'll just keep doing 1/4 inch bends until you curve this over. And that's how you create that. Now I am going through 2 inches of flooring. So I am going to add 2 inches here. So the next thing you want to do is whatever kind of method you're going to use. I use a groove seam. So you, on a groove seam, you add 3/8, but you only bend 1/4. You could rivet it, you could do whatever you want. Now when you get to your collars, a lot of times I'll make a collar, but a lot of times I'll cheat. I'll just get a long tabbed collar from the supply house. I'll stick it in there and I'll spot weld it from the inside, save me the trouble of making a collar. But it's not that hard to do. Then of course you want to add to the top for whatever you are going to do up here. You're going to do a peened edge. You'll add 1/4 to it. So there you have it. Like I said, you put this in the brake, and you could do your curve. Just anchor one each corner in the brake as you go, and just create an arc with the brake from these points here and these points here. And you are done. Hope you enjoyed the video. Please like and subscribe. We'll see you in the next one.